Box and whisker plots. Today our focus is on being able to create a box and whisker plot, and not so much just create one, but actually use it to help us understand information. And so in order to get started, I need for you to make a box and whisker plot from this information. Now this should be a review of what you learned last year in 6th grade, so now would be a good time to pause the video. All right, welcome back. So in order to make a box and whisker plot, we need to know a couple of things. First, it's helpful to have our data in numerical order. So 2, 3. Notice how I'm crossing each term out with just a simple dash through the number. That way I can still see what the number is in case I make a mistake and need to come back to it. 9 and 9. 12. 15. All right. So I have 1, 2, 3, 4, 5, 6, 7 numbers. So the middle of 7 numbers becomes 4. So it's going to cross right through there, which gives me 3 numbers on my lower bound. So the middle there is here. And it gives me 3 numbers on my upper bound. So the middle there is 12. Now, what does that mean? This means that that is our median. This is our Q3. This is our Q1. Now we talked about these different quartiles when we were talking about IQR way back at the beginning of the unit with variation. So this information so far should look pretty relatively consistent with what we've already discussed. Now I'm going to give you a nice easy way to make a box and whisker. We're going to start with a number line, and our number line needs to extend from our lowest value up to our highest value. So somewhere down here, I have a 2. I may as well go ahead and start at 0. It's not going to hurt anything. 2, 4, 6, 8, 10, 12, 14, 16. Again, I went by 2s up to 16. It's not going to hurt anything to go just a little bit past our data set. Next. I generally recommend we find our Q1, our Q2, and our Q3. So our Q1 is at a value of 3 that would be halfway between 2 and 4, and make a line. Our Q2 is at 9, halfway between 8 and 10, make a line. Our Q3 is at 12, make a line. Those are our quartiles. And quartiles are what constitute our box. So by making lines, I knew exactly where my box was going to close. Next, we want to find our highest value and our lowest value. Our lowest value is 2, so that comes down to here, and it's a whisker to the box. Our highest value is 15, so that's going to be somewhere right up here, and that's a whisker to the box. Now again, you should have made box and whisker plots in 6th grade, so this should be all review. Couple of things I want you to be sure that you know as we progress forward. 5-number summary is a set of numbers calculated from collected data or numbers. The 5-number summary is going to consist of a minimum value, which we know is the lowest number, quartile 1, or you can abbreviate Q1, median Q2, quartile 3, Q3, and maximum number, the highest number. These 5 items are what we call the 5-number summary. It's going to be good for you to know that. You're going to use it a lot as you do data analysis with box and whiskers. Distribution shape and box and whisker plots. Now, distribution shape, we talked a little bit previously about skewed left, skewed right, and symmetric data. We are going to look at that more when we get into histograms, but I want to just be able to show you some similarities between the curves and the box and whiskers. Notice with skewed left, the bulk of our data is on the right side, and our box tends to lean itself more to the right side. Now, since this is showing us medians, we know that 50% of our data is going from here to here. That's a lot of data in a highly consolidated area. All right, now when we have what we call normal distribution, we have a normal bell curve, our box tends to be more centrally located. Now, yes, it will vary if it's not perfectly normal. We've talked about that a little bit before with the bell curve. I'm not going to get onto us much if we extend outside or if our median is not exactly inside the middle of the box. It can deviate just a little bit, and I will still accept symmetric as a reasonable answer. Right skewed, the bulk of the data is on the left side. So notice again, 50% of my data is heavily concentrated in one section. Let's make another box and whisker plot. Again, pause the video, go ahead and make this on your own, and then come back and see how you did. All right, let's see how you did. So the first thing we want to do is we want to take all of our numbers and put them in numerical order. So it looks like 20 is my smallest number. I see a 21. I see a 22. Let's see, I see a 24 and a 28. 29 and 29. And 33. So again, we'll count them. 1, 2, 3, 4, 5, 6, 7, 8 total numbers. So I should be able to split 4 and 4. Sure enough, I can split it here. That means I have a lower bound of 4 values, so I should be able to split it 2 and an upper bound of 2. All right. Now we need to find all these values because we know our median is the value that sits directly between 24 and 28. Now it's nice and easy when they're even skips like that. So, because 24 and 28 would have 25, 26, 27, 28. So 26 is naturally our median. If you need to, again, you can add the two values together and find the value in the middle. 29 and 29, there is no value in the middle of 29. It would be 29. 21 and 22. So again, we're going to add them up, divide by 2, and we end up with 21.5. So we need a box and whisker plot that goes from 20 to 33. So let's start at 20, 22, 24, 26, 28, 30, 32, 34. All right, so again, I generally like to get my lines on from my box. So we're going to have our first line at 21.5. That's going to be down here pretty close to, let's see, a little higher than 21. Our next value, 26. Our next value, 29. All right, we want our whisker to go down to 20. We want our whisker to go up to 33. Now, where is our data? It would appear that the bulk of our data is to the left, so we would call this skewed right. Let's try another one. Again, pause the video. All right. I'm going to go ahead and give myself a number line. And so I already gave you these numbers in numerical order. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we want to split it in half. 1, 2, 3, 4, 5 numbers. So our halfway point is going to be here, which means I now have 5 numbers in my lower bound, halfway point, 5 numbers in my upper bound, halfway point. So we need data that goes from 3 to 11. So I'm going to go ahead and start down at 2, 4, 6, 8, 10, 12. So let's put on our values that we know. Our Q1 is 3. Our Q2 is right between 4 and 5. So 4 plus 5 is 9. Divided by 2 is 4.5. So we're looking at 4, not quite to 5. Come back just a little bit. That gives us 4.5. And 8. Yeah. Since you have got paper and a ruler, your box and whiskers should look a little bit more precise than mine because I'm drawing on a slate that doesn't really have any identifying markers for me to be able to keep everything perfectly lined up. All right, our uppermost value is 11, so we need a whisker. Our lowermost value is 3. Well, 3's right there. What in the world are we going to do? Well, you're welcome to try to put a dot there. I don't really need it. If you leave your graph just like this, guess what we all know? We all know that your lowest value sits on this line. So your lowest value and your Q1 are identical. Now, a couple other things for us to look at while we're here. The median is the center of our data. The distance from Q1 to Q3, that's the size of the box. But we also know Q3 to Q1, the difference is our IQR. So in this case, our IQR is equal to 8 minus 3, which is 5. That might be helpful for us to know and be able to extrapolate from a graph. Now, this is our real focus for this year, is to be able to take not just one set of data, but 2 sets of data and compare them. So the very first thing we're going to want to do is take this data and put it in numerical order. So 62, 77, looks like we got an 83, 86, got an 89, 93, oops, 93, 93, and a 99. So I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. I had 1, 2, 3, 4, 5, 6, 7, 8 numbers. We're good. And so this is generally where I highly recommend that you have your 5-number summary. It's good for the previous problems, but we didn't need it because we were only comparing one set of data. Now we're comparing 2, and it's going to benefit you to write it down. So lower extreme, Q1, Q2, Q3, highest extreme. So here our lowest extreme is 62 from group A. Our highest extreme is 99, and now we need to figure the ones in the middle. We said we have 8 numbers, so between the 4th and the 5th number is our median, 86 and 89. 86 plus 89 gives us 175, divided by 2 gives us 87.5. So I may as well go ahead and write that over here. All right. Now we have 4 numbers in our lower bound, so we want the number in the middle. So it's going to give us 77 plus 83. And again, we're going to divide it by 2. And so that will give us a value of 80. Let's find our Q3. Well, we have a 93 and a 93. That one makes that very easy. 93. Now let's compare that with test group B. So test group B has a 68, 76, 79. Has an 81, 85. Has a 93 and has 100. So we start with our median number in the middle. I have 1, 2, 3, 4, 5, 6, 7 numbers, so the 4th one is going to be my median. 81. All right. Well, we could go ahead and get our lowest extreme, 68, and we can get our highest extreme, 100. And then we want the Q1. Well, if I have 3 data points here, the Q1 is going to be the value in the middle, so 76. If I had 3 data points here, the Q1 is going to be the one in the middle, so 93. Now, just looking at our chart, we should start to see some similarities and be able to draw a comparison, but we're going to now make a box and whisker. Notice with the box and whisker, I need my number line to go to the lowest value in both sets and the highest value in both sets. So probably 60 to 100. 60, 70, 80, 90, 100. Well, since those are all spaced evenly, I'm going to knock that one out. We'll call this 60, 70, 80, 90, 100. I often encourage students to give a midpoint hash mark just so that they know where the middle of that set of data is. Just helps with lining up values. So let's pick a group. We want to start with group A. And now I'm going to graph group A onto this particular number line. So I want its lowest extreme, which is 62. That's going to be somewhere down here. I want the Q1, which is 80. That's way up here. I want the Q2, which is 87.5. So 85, 87.5. Notice these are going to be kind of approximations, but again, you should be able to be a little bit more accurate on a piece of paper with a ruler. We want a 93, so 91, 2, 3. And we want a 99. Almost to 100. So let's close in our box. Let's attach our whiskers. And we have a box and whisker for group A. Now, what can we see about group A? We see that the bulk of the data is over here on the right. Good chance that this could be skewed left. All right. There we go. So now let's go on to group B. Notice how I've labeled my two groups. Well, granted, I point out I labeled when I messed up on writing, but that's okay. I've labeled my two groups so that when you're looking at the graph, you know which one is which. If you don't label it, I will take off points. It'd be nice to have some sort of title or heading underneath. Test scores. Values. And this is a comparison of test scores. Now, you're not always given what the data represents. If you're not, that's okay. You're welcome to just put sample data as your title, and then you can still put information on the number line. All right, so we have our 68 as our lowest extreme, so that should be closer to the 70 here. We have a 76 as our Q1. We have an 81 as our Q2. We have a 93 as our Q3, so that should be in the same spot. I did not make that in the same spot. Let's try that again. So we have a 93, actually, way up here. And then we have a 100 as our highest extreme. So we come back to the box, we close in our box. All right. Now, I would probably call this skewed right because we're going to see a heavier portion of our data grouped to the left. From here, we can make a number of observations. Let's talk about some of those observations. Perhaps we could talk about the range. Which one has a higher, which one has a lower range? Well, group B has a lower range because its distance from the top point to the lowest point is smaller. Which one has a lower variation based on the IQR? Well, if we're talking about IQR, then we're looking at the size of the box. So group A has a much smaller box. It has less variation based on the IQR. Well, what about measures of center? Can we talk about the median? Well, we do see that the middle number, the Q2, is our median. So group B has a lower median, where group A has a higher median. We don't really get a good sense of range. Not range. We don't really get a good sense of mode, and we don't get a good sense of mean from a box and whisker plot. But we can get range, IQR, and median all out of a box and whisker plot. And that's at least enough to do a reasonable analysis of the data. Appropriate measures. When both sets of the data are symmetric, the appropriate measure is the mean. When both sets of data are symmetric, the appropriate measure of variation is the mean absolute deviation. Now, we are not going to calculate mean absolute deviation in this course. So for variation, I will let you use range or IQR. If the data is not symmetric, which falls into both of these categories, then the appropriate measure of center is the median, and the appropriate measure of variation is the IQR. Now, this should sound familiar because we talked about this when we had outliers. So when you have outliers, use the median and use the IQR. Non-symmetric data works the very same way. So, symmetric data. Symmetric data tends to have the median in the middle of the box, and the box is relatively centered within the set of data. Skewed left or skewed right. The skewed left or skewed right, the median tends to be slightly off-center, although it doesn't have to be. But the box itself is typically off-center. So if your box itself is pushed to the left, we would call that skewed right. If your box itself is pushed to the right, we're going to call that skewed left. Now our skewed right and our skewed left would be non-symmetric, and so they would fall into the IQR and median appropriate measures of center. Now, how are we going to use mean if we don't have the data for it? One of the things we want to know about or remember about symmetric data, or I guess learn about symmetric data, is that it follows our typical bell curve. And we've seen this before. We're going to see it again when we talk about histograms. And within a typical bell curve, your data tends to work its way up at an even rate that it works its way down. Additionally, if you have a perfect bell, your mean, your median, and your mode all fall into the same spot in the center. If you do not have a perfect bell, and that's where your median can shift just a little bit here, I'm okay if it shifts just a little bit, as long as we're in the same general realm of the middle, and same here, as long as we're relatively close to being even. Then your mean, median, and mode are all going to fall relatively center around your median. Percent of the data. Now, it's important for us to remember that each one of these grids is 25%. So that represents 25% of my data right there. 25% of the numbers used for this histogram fall between 16 and 18. 25% of my data then falls between 18 and 22. We don't know what the actual numbers are, but we do know that 25% of them fall within that range. 25% of my data falls between 22 and 26. And then lastly, 25% of my data falls between 26 and 28. And so we could ask questions like, where is the upper 75th percent of the data? And the upper 75th percent of the data would be from here to here. So that would fall between 18 and 28. We could ask a question like, what percent of the data falls between 18 and 26? And then we would say that is the middle 50%, which is the IQR. The middle 50%. You're going to now compare box and whisker plots. And there's 4 on the sheet and only 4 on the sheet, but I want you to compare the 4. Figure out which box and whisker goes to which set of information, and then provide me with a quick justification on how you were able to figure that out. Your justification is going to get loaded into CTLS, so take a little bit of time making sure that you're thinking through it and answering it correctly. And have a good day.